Hi student, my name is B. Upender. I am going to explain solid state chapter class 12. This is the first session. In this session, I am going to discuss easiest explanation and tricks for types of unit cells. There are three types of unit cells are present. In that, the first one is one-dimensional unit cell. One-dimensional unit cell. In one-dimension unit cell, atoms are arranged like this. Atoms are arranged like this. If you imagine these atoms or ions in the crystal lattice, they are arranged like this, like points. So the distance between these any 2 points we can represent it with the letter A. So in order to define the one-dimension unit cell, we required only one parameter, that is A. So the second one is two-dimensional unit cell. 2D unit cell. In two-dimensional unit cell, atoms are arranged in this manner. In two-dimensional unit cell, atoms are arranged in this manner. If we imagine in crystal lattice structure, these atoms are represented like this. Lattice points. Here, this is A, this is B. Here angle is theta. So, in two-dimensional unit cell, there are three parameters are required to define the two-dimensional unit cell. So, in two-dimensional unit cell, again classified into 5 types. Types of 2D unit cell. Types of 2D unit cell. In this one, first one is square unit cell. square unit cell. In square unit cell, A is equal to B, theta is equal to 90 degrees. The second one is a rectangular unit cell. In rectangular unit cell, A is not equal to B, but theta is equal to 90 degrees. Third one, hexagonal unit cell. Hexagonal unit cell. Hexagonal unit cell, it is like this. A is equal to B, but theta not equal to A equal to B, but theta is equal to 60 degrees. Theta is equal to 60 degrees. The fourth one is rhombic unit cell. In rhombic unit cell, A is equal to B, but theta not equal to 90 degrees, theta not equal to 60 degrees. The fifth one is parallelogram unit cell. Parallelogram unit cell. In this one, A not equal to B and theta not equal to 90 degrees. These five arrangements these five arrangements are called Bravis lattice in 2D. So these five types of arrangements in two-dimensional unit cell are called Bravis lattices. How many Bravis lattices are possible in two-dimensional unit cell means 5. So next third one is three-dimensional unit cell. Three-dimensional unit cell or three-dimensional unit cells. In three-dimensional unit cells, atoms are arranged in this manner. Atoms are arranged like this. In three-dimensional unit cell, atoms are arranged like this. In three-dimensional unit cell, atoms are arranged like this. Three layers are there. In this one, here, if you observe the crystal lattice, this is A, this is B, this is C, this angle is alpha, this angle is beta, this angle is gamma. In three-dimensional unit cell, three parameters are required to define three-dimensional unit cells, again classified into 7 types. Three-dimensional unit cells, again classified into 7 types. Types of (3D) unit cells. First one is simple cube. First one is simple cube, or we can also call it as primitive type. It means all atoms are present at corners only. Simple cube. This is the simple cube. Here 6 parameters are required. This is, in this one, this is A, this is B, this is C, this is alpha, this is beta, this is gamma. Here A is equal to B is equal to C, alpha is equal to beta is equal to gamma, that is equal to 90 degrees. The second one is tetragonal unit cell. In tetragonal unit cell, to get tetragonal unit cell, just elongate this simple cube upside, we will get the tetragonal unit cell. It is like this. In this one, A is equal to B, not equal to C, and alpha is equal to beta is equal to gamma is equal to 90 degrees. This is in this one. This is A, this is B, this is C. This is alpha, beta, gamma. Right. Next to hexagonal unit cell. Hexagonal unit cell. Hexagonal unit cell. It is this is hexagonal unit cell. In this one, A is equal to B but not equal to C, and alpha is equal to beta, that is equal to 90 degrees, but gamma is 120 degrees. This is gamma, 120 degrees. Right? This is A. This is B, this is C. Hexagonal unit cell. Then orthorhombic unit cell. Orthorhombic unit cell. Orthorhombic unit cell, it is like a matchbox. Here A not equal to B, not equal to C, and alpha is equal to beta is equal to gamma is equal to 90 degrees. Next one, rhombohedral unit cell. Rhombohedral unit cell. In rhombohedral unit cell, it is exactly opposite to the orthorhombic unit cell. So A is equal to B is equal to C, and alpha not equal to beta, not equal to gamma, not equal to 90 degrees. right? Next one, monoclinic unit cell. Monoclinic unit cell. In monoclinic unit cell, it is monoclinic unit cell. A is just like orthorhombic, A not equal to B, not equal to C, but alpha is equal to beta is equal to 90 degrees, but gamma is not 90 degrees. This is monoclinic. Seventh one, triclinic unit cell. In triclinic unit cell, A not equal to B, not equal to C, and alpha not equal to beta, not equal to gamma, not equal to 90 degrees. These 7 types of arrangement in 3-dimensional unit cells are called Bravis lattices. So these seven types again we can arrange into 4 types. These 7 types unit cells are again we can arrange into 4 types. That 4 types are these 7 types unit cell again arranged in arranged in 4 types. The first one is simple or primitive. Simple or primitive. In this one, atoms are arranged at corners only. That is, in simple or primitive type, atoms are arranged at corners only. Second one is body-centered cube. Second one is body-centered cube. In short, it is BCC, or simply you can write BCC, right? In body-centered, atoms are arranged corners plus body of unit cell. Right? This is BCC. Third one, face centered cube. Face centered cube. In short, it is called FCC or CCP. It also called CCP also. In this one, atoms at corners plus center of faces. If you see face centered unit cell, it is corners plus face. This face and this face, this face, this face, and this face is this one, and this back side face this one. Like this is the face centered cube. The fourth one is end centered cube. End centered cube. In end centered cube, atoms are at corners plus any corners plus any two opposite faces. Any two opposite faces. It is like this. See here, corners so any two opposite faces means if you take these two opposite faces like this in three-dimensional unit cells, these 7 types of unit cells you can again arrange in four ways. That is simple cube, body centered, face centered, and end centered. See here, orthorhombic we can arrange in 4 ways. Orthorhombic unit cell we can arrange into 4 ways: simple cube, BCC, FCC, and end center. Then simple cube we can arrange in 3 ways: simple cube we can arrange into 3 ways: SC, BCC, FCC. Monoclinic we can arrange into 2 ways: monoclinic we can arrange into 2 ways: simple cube and end center. Monoclinic. And tetragonal we can arrange into 2 ways: tetragonal. It is also simple cube and basis. Remaining hexagonal, rhombohedral, triclinic. These 3 unit cell we can arrange only in simple cube only. So here this one is 4 ways. Here this is 3, this is 2, this is also 2, 4, 3, 7 to 9, 9 to 11. Here each one, each one means this is 3. Total arrangements is 14. Simple cube how many? This is also 3, 1, 1, 1. 3. So total arrangement or total Bravis lattices are 14. In 3-dimensional unit cell, total Bravis lattices are 14. In 2-dimensional unit cell, total Bravis lattices are 5. And see, this is the first session. If you like this video, please subscribe to get more videos.